Chapter 1.4 Motion along a straight line. 1. Expressing vectors along a straight line. Displacement, velocity, and acceleration of vectors. People usually use right is positive convention. That means vectors point to the right are positive, while vectors point to the left are negative. For vertical motion, people use upward is positive convention. So, in the following example, the displacement from A to B is positive 200 meters, and from B to C is negative 1000 meters. So the total displacement from A to C will be given by positive 200 plus negative 1000 that equals negative 800 meters. The negative sign indicates its direction to the left as shown in the diagram. In table 1.4a, we calculate the average velocity. When there is a change in displacement, there is a non-zero velocity. So the velocity at B is 0 as there is no change in displacement. Velocity and displacement are both vectors, so a positive velocity points to the right and a negative one points to the left. And now try chapter 1.6 below. Two, accelerated motion. A. Magnitude of acceleration. In figure 1.4c, there is a taxi and a sports car. Both accelerate uniformly, which means accelerate with a constant acceleration. The sports car runs faster, which means its speed is higher. The sports car also accelerates with higher acceleration, which means its velocity increases more quickly. Since both cars start from rest, the sports car takes less time to reach a highest speed and travels a longer distance after the same time interval. Let's plot a graph to show how the velocities of the two cars change with time. The velocity time graph of the sports car has a steepest slope. Why? You may refer to page 46 for the explanation. By the way, a higher acceleration does not necessarily mean a higher final speed. If the acceleration takes a very short time, the final speed can still be very small. In example 8, we compare the acceleration of a train and a sports car, which echoes the Let's Begin section. The train has a higher final speed, but its acceleration is indeed much smaller. The much greater acceleration of a sports car is uncomfortable to both passengers as well as the driver. B. Direction of acceleration. 1. Direction of acceleration and direction of motion. The direction of motion is the direction of velocity. As you may have learned from your last assignment question, question 20 on page 45, when an object speeds up, its velocity and acceleration should be in the same direction, while when the object slows down, the acceleration and velocity should be in opposite directions. In other words, the direction of acceleration alone does not tell whether the motion is speeding up or slowing down. We must also know the direction of the velocity at that time. 2. Motion with a change in direction. If the acceleration and velocity are opposites in direction, an object is slowing down. It is decelerating. The speed will become less and finally becomes 0. What if the deceleration continues? In figure 1.4f, a car starts with velocity 8 meters per second and decelerates at 2 meters per second square. Its velocity decreases by 2 meters per second. So its velocity becomes 6, 4, 2, and then 0 after 4 consecutive seconds. And if the deceleration continues, its velocity then becomes -2, -4, -6, -8 meters per second in the next consecutive 4 seconds. The acceleration of the car is constant at 2 meters per second square to the left. However, we can see that it slows down in the first 4 seconds and then speeds up to the left in the last 4 seconds. The car is said to be momentarily at rest at t equals to 4 seconds when its speed is 0, and then it changes its direction of motion at that time. It starts to run in opposite direction to the left. Similarly, you may also toss a coin into air and observe its motion. It was fast when it just left your hand, and then it slowed down as it rose, and became momentarily at rest at the highest point, and then speed up again as it began to fall. In example 10, the downward acceleration of a handball player when he jumps is calculated. Now try 12.7, and then the quiz following the video.